Hi friends, you're watching GATE Helpline, and in this video we will see GATE 2017 CS question paper subject-wise solution for data structure. Friends, please hit the subscribe button and click the bell icon to get all the latest updates from our channel regarding GATE exam. So friends, let's start taking questions one by one. Question number 5 is, consider the following table. In this table, the algorithms and their design paradigms are given and we need to match these. And the options are these: A, B, C and D. Now we will see a brief introduction of these algorithms one by one. Kruskal algorithm is a minimum spanning tree algorithm which finds an edge of the least possible weight that connects any two trees in the forest. It is a greedy algorithm in graph theory as it finds a minimum spanning tree for a connected weighted graph, adding increasing cost arcs at each step. Quicksort is a highly efficient sorting algorithm and is based on partitioning of array of data into smaller arrays, that is divide and conquer approach by dividing the input arrays according to pivot element. For Floyd-Warshall algorithm is used for finding shortest path in a weighted graph with positive or negative edge weights but with no negative cycles. Use dynamic programming. So for Kruskal algorithm it is a greedy algorithm, and for Quicksort it used divide and conquer paradigm, and for Floyd-Warshall algorithm it uses dynamic programming. So answer to this question is P maps to second, Q maps to first and R maps to third. So as per our discussion, answer to this question is option C. Question number 6 is, let T be a binary search tree with 15 nodes. The minimum and maximum possible heights of T are. Note, the height of a tree with a single node is 0. And the options are 4 and 15 respectively, 3 and 14 respectively, 4 and 14 respectively, and 3 and 15 respectively. So the explanation to this question is as follows. BST, binary search tree. For minimal height, we have formula log base 2n minus 1. For maximum height, we will have a continuous chain of length n, total number of nodes, hence giving us a height equals to n minus 1, that is, as height starts from 0. So for minimum height, we can equate n is equal to 15. So log base 2 15 minus 1, that is 3. For maximum height, it's n minus 1, that is 15 minus 1 equals to 14. So as per our discussion, answer to this question is option B, that is 3 and 14 respectively. So question number 11 is, consider the C struct defined below, and the struct is this. The base address of student is available in register R1. The field student.grade can be accessed efficiently using, and the options are A, post increment addressing mode, B, pre-decrement addressing mode, C, register direct addressing mode, and D, index addressing mode X of R1, where X is an offset represented in 2's complement, 16-bit representation. So friends, this is a kind of memory allocation for struct. Here the first 100 byte of blocks of 4 bytes are allocated to marks array, and then 1 byte to grade, and at last the 4 bytes to C number. So here don't go block by block, we have just depicted the memory allocation for the struct block. So here the address of student grade can only be accessed by using the base address of student. So this one is the base address, and this is the displacement we need to cover to access this grade character. So we will see all the options one by one whether they are correct or not. So first one is post increment addressing mode. So in this addressing mode we will give the next address and not the student graded address. In pre-decrement addressing mode, this will give the previous address and not the student grade address. And in the register direct addressing mode, in this addressing of the operand is embedded in the instruction code, and at last the index addressing mode. In this, the only mode gives access to the next address by adding the displacement to the base address using displacement mode. So the base register contains pointer to memory location, and integer constant is referred to as displacement, and the address to the operand is obtained by adding the content of the base register plus constant, that is the displacement. So the address of the operand, that is this 1 byte char, we can get with the help of base address and displacement, which is this one. So therefore option D is correct. So friends, as per our discussion, answer to this question is option D, that is index addressing mode. So the question number 13 is, consider the following C code, and the following is the C code. The code suffers from which one of the following problem? And the options are A, compiler error as the return of malloc is not typecast appropriately. Option B, compiler error because the comparison should be made as x double equals null and not as shown. B, compiled successfully but execution may result in dangling pointer. And D, compiled successfully but execution may result in memory leak. Now we'll see explanation towards each option one by one. Option A is wrong. C does automatic implicit typecasting. We don't need to cast the result, as void star is automatically and safely promoted to any other pointer type in this case. Option B, it is discarded for obvious reasons, because x double equals null and null double equals x both are same, because here we are only performing the comparison operator is being used and we are performing comparison. Option C is wrong, because dangling pointer is nothing but the pointer which is pointing to non-existing memory, deallocated or deleted memory, which is not happening here. Option D is the answer. When you are calling malloc second time, new location is assigned to x and previous memory location is lost, and now we don't have no reference to that location, resulting in memory leak. So as per our discussion, answer to this question is option D, that is compiled successfully but execution may result in memory leak. Question number 26 is, let G equals to V comma E be any connected undirected edge weighted graph. The weight of the edges in E are positive and distinct. Consider the following statements. First, minimum spanning tree of G is always unique. Second, shortest path between any two vertices of G is always unique. Which of the above statements is or are necessarily true? And the options are A, first only, B, second only, C, both first and second, and D, neither first nor second. Now we will see explanation to this question. Point first is, minimum spanning tree of G is always unique. That is, MST will always be distinct if the edges are unique or distinct. So this point is correct and there is no need to explain it further. Point second is, shortest path between any two vertices of G is always unique. Shortest path between any two vertices can be same. So this is incorrect. So we will see this with the help of the below graph. In the below graph, we can see a graph having 4 vertices and 5 edges. And in this graph, we need to find the shortest path from A to C. And as we can see, there are 2 paths which we can find from A to C as A, B and C, and direct A to C, and the weight of both these paths are same, that is 3. So this proves that the second statement is incorrect, that is shortest path between any two vertices of G can't be unique. As per our discussion, answer to this question is option 1, that is first only. Minimum spanning tree of G is always unique. Question number 35 is, consider the following two functions. These are the two functions, function 1 and function 2. The output printed when function 1 phi is called is, and the options are A, B, C and D. Now we will see explanation to this question. These are the two functions, function 1 and function 2. In function 1, we are checking if n equals to 0, then we return. Later, there is a print condition that's going to print the value of n. After that, there is a call to function 2 with reducing the value of n by n minus 2. And then there is a print condition which prints the value of n. In function 2, it's a void function, which simply means it's not going to return anything. This function will simply execute and come here. In this function also, there is a if condition which checks for value of n equals to 0. If that value equals to 0, it will return. In the next line, there is a print condition which prints value of n. Then there is a call to function 1 which pre-increments the value of n. And here is the main concept, because the pre-increment is a unary function which will increment the value of n here itself. Then there is a print condition which prints the value of n. So now we will see this with the help of value of n as phi. So here we have function 1 so now we have function 1 with a parameter value of phi. So in this, when we run, there will be a print to value of n as phi, then call to 3, then there is a print condition of phi. So here it's clear that the starting value and the end digit in the output is going to be phi and phi only. So now we check for the function 2, and function 2 we have passed value as 3. So here it will print 3, and then it will check for function 1, and the parameter value is incremented. So this here the value of n is incremented from 3 to 4, and the value of n will be having now the updated value, that is 4. So in the next line it is not going to print 3, it will print 4. So the output will look like this. It will start with phi 3 and end with 4 phi. So instead of solving the entire program, now we will see the options and try to eliminate them to get the correct answer. So these are the options. Now here in this we can see that option A is starting and ending with phi, option B is not ending with phi, in option C it's starting and ending with phi, but in option D it's not ending with phi. So it's clear that option B and option D are wrong. So now we check for the second and second last digit. In A and C, the second digit is 3, that is correct, and the second last digit in A is 4, but in C it's 3. So C is eliminated. So what is left is option A. So as per our explanation, answer to this question is option A. So friends, thanks for watching our video. Please like, subscribe our channel and share our videos to appreciate our work. If you have any doubt or question, please comment below and keep watching our channel for videos like this.